Marine energy extraction is often hailed as a clean and renewable solution to our energy needs. Tidal, wave, and offshore wind systems promise a sustainable future. But beneath the surface, there are hidden costs that we must confront. Let's start with habitat disruption. When we install these energy systems, we're not just placing turbines in the water, we're altering ecosystems. Marine life, from fish to whales, can be significantly affected. The underwater noise pollution generated by these systems can interfere with the communication of whales and dolphins, disrupting their natural behaviors. Imagine navigating through a world of sound that's suddenly filled with machinery. It's not just an inconvenience, it's a threat to their survival. Then there's the alteration of tidal patterns. Changing how water flows can impact fish migration routes, which are crucial for their life cycles. If we disrupt these paths, we risk not only the fish populations, but also the communities that rely on them for their livelihoods. Installation processes can disturb the seabed, leading to increased sedimentation that can smother delicate habitats. Maintenance is another beast entirely. The ocean is a harsh environment, and keeping these systems operational is both difficult and costly. Long-term issues like corrosion and biofouling can significantly reduce efficiency. We often underestimate the carbon footprint associated with manufacturing, transporting, and deploying these massive structures. It's not just about the energy they produce, it's about the energy it takes to get them there. And let's not forget about navigation hazards. These installations can pose risks for ships and fishing vessels, creating potential conflicts on the water. Visual pollution is another concern. Coastal tourism can suffer when the landscape is dotted with turbines and platforms. The infrastructure needed to connect these systems to the grid can disturb shoreline ecosystems, and the electromagnetic fields from underwater cables may affect sensitive species. Local fishing communities might find themselves losing access to key fishing zones, leading to economic strain. Legal jurisdictional issues can arise, creating disputes that complicate project development. Monitoring the deep-sea effects of these installations is expensive and still in its infancy. We're still learning about the potential entanglement risks for marine mammals and the threat of invasive species introduced through construction equipment. Insurance costs are sky high due to the unpredictable nature of the ocean, and the life cycle cost per kilowatt hour can be higher than anticipated, especially without subsidies. Policy frameworks are still evolving, leading to regulatory uncertainty that can stall projects. Some initiatives have been abandoned after failing feasibility assessments, highlighting the risks involved. Weather unpredictability can impact energy consistency, making it difficult to rely on these sources as stable energy providers. Long-term ecological shifts, like changes in plankton blooms or reef health, remain largely unstudied. We must consider the potential conflicts between military zones and migratory paths with marine energy zones. Noise and vibration from these systems might disrupt benthic organisms, further complicating the ecological picture. Transmission line losses over long distances can affect overall efficiency, and decommissioning marine structures is an often overlooked aspect of planning that can be extremely costly. So, while marine energy holds incredible promise for a sustainable future, It's crucial that we evaluate these lesser-known costs. Only by addressing these challenges can we ensure a responsible and sustainable blue energy future.